Hi everybody, in this video, I want to show you how to solve quadratics using what's called the square root property. So first of all, the square root property says the following. If b is a real number and if a squared equals b, then a equals plus or minus the square root of b. So basically, to solve for a, we can take the square root of both sides. And that is a valid and viable way to solve. Now, the thing I want you to note here, and you can see the first couple examples I have on this page, is that this works really well for quadratics that only have variables being squared. So again, when would you want to use the square root property to solve? I would use it when all variables are squared. So there is no regular x term. So notice in my two examples here, it's x squared equals 9, x squared equals 50. So there's no extra x term, right? It's not x squared plus 2x equals 9. That's when the square root property is really nice, when your variable is being squared, and that is it. So when that's the case, what you're going to do is take the square root of both sides. You do want to have your square by itself and isolated, so that's important. So the square should be by itself. One side of the equation. So if it's not, you do want to rearrange things so that the square is alone. And then you're going to take the square root of both sides. When you do that, it's always plus or minus the square root. That square root and square will cancel. You're left with x here. And then on the other side, you have plus or minus the square root of 9. Now, the square root of 9 is just 3 here. So you have two solutions, positive and negative 3. So you have positive 3 and negative 3 as your answers, or in set notation, you can write this as 3 comma negative 3 with those squiggly brackets. Let's try another one. So again, my square is already by itself. Everything else is on the other side. So I'm going to go ahead and take the square root of both sides. Don't forget the plus or minus. The square and square root will cancel. So I have x equals plus or minus the square root of 50. Now, 50 is not a perfect square, but I would see if I could simplify this at all. 50 is 25 times 2, and 25 is a perfect square. So I can at least break this down a little bit. That becomes 5 root 2. And again, you have two answers. So you have positive 5 root 2, and you have negative 5 root 2 here. So two answers when solving are quadratics like this, using that square root property. Now, one thing I will note is that if you have an application that you're solving, the negative or maybe the positive may not always be relevant. So when we solve, it's always plus or minus the square root. But of course, if you have a more of a word problem there, you may have to analyze that afterwards and see what makes sense. Sometimes they both make sense. Sometimes maybe only one makes sense. But we do always start with the plus or minus idea. And then after the fact, again, if you have some sort of application-based problem, you can decide the relevant answer there. But here we do have two answers when solving. All right, let's do a couple more examples. Now for this one here, notice that my square is not by itself. So I am going to start by getting the square alone. So I'm going to go ahead and add 14 to both sides. So I have 2x squared equals 14. I'm going to divide both sides by 2 here. And finally, I have my square totally by itself, x squared equals 7. Now, once that is the case, I can go ahead and take the square root of both sides. So my final answer is x equals plus or minus the square root of 7 here. I cannot break down the square root of 7 at all. So that is going to be it for my answer. And again, if you prefer, you can write this as set notation. But just keep in mind you have two answers here. One is positive root 7 and one is negative root 7. And you could also use your calculator here if you needed an estimation. But the big thing I want you to notice in each of these examples is that there was no x term, right? All the variables were being squared. So when that's the case, this property is really nice and an easy way to solve quadratics. Now, the next example looks a little trickier because you may be saying, well, hey, this is an x, right? But if you look really carefully, that x term is being squared. It is in parentheses, so it is being squared. So there is, the variable is always being squared in this example. So when that's the case, I can use the square root property. You still want to make sure your square is by itself, which it is. And then you're going to take the square root of both sides. And again, plus or minus. So on the left side, I'm going to have x plus 1. On the right side, I have plus or minus root 12. Now, 12 is 4 times 3. So I can break this down a bit. I get root 4 times root 3. So that would be 2 root 3. So I have x plus 1 is equal to plus and minus 2 root 3. And then I would still want to get the x by itself. So I would subtract 1 from both sides. So we often write the answer like this. I would probably put the -1 first, plus or minus 2 root 3. It does give you two answers though. So one answer is -1 plus 2 root 3. And then the other answer would be -1 minus 2 root 3. Now, these look a little bit funny for answers, but they're real numbers. So if I just take out my calculator for a second, just so you can see. So if I type in -1 plus 2 times the square root of 3, and I hit enter, I get the value about 2.46. So they're real numbers. They just look kind of messy. And the other one is -1 minus 2 times the square root of 3. And I get about -4.46. So a lot of times our answers may look really messy here, but if you type them in, they are real number answers. So you could always get a decimal approximation if the problem wants that. Now, the last example I'm going to do here is very similar to this one. Now, if you look closely, you'll notice that the only x here is being squared. So even though it may not jump out right away to use square root property, if I look closely, all the x's are being squared. So that's a great opportunity to use the square root property. You do want to make sure your square is by itself, though. So before I do anything else, I'm going to add the 4 to both sides. And I'm also going to divide out this 3. Again, I want that square to be totally alone here. So I have x plus 2 squared. 9 divided by 3 is equal to 3. So that's really important that you get that square by itself. Otherwise, when you square root it, it's not going to work right. So now I can go ahead and take the square root of both sides. So I have x plus 2 equals plus or minus the square root of 3. Now I can't break down the square root of 3, so I'm just going to subtract the 2 from both sides, and I'm going to get a final answer of -2 plus or minus root 3. And again, you do have two separate answers here. One is -2 plus root 3, and one is -2 minus root 3. So you do have two values, and if you want to plug those into the calculator, you could get approximations for those. But here, when you're solving quadratics, if you want to use the square root property, the key is that the x's or whatever variable you're using has to all be squared. So that's really important. If you have extra x terms hanging around, it's just not going to work out well. So if you have all your x's being squared, this is a great property to get the answer relatively quickly for a quadratic problem.